Welcome to the login node. This is Will. In episode 6, we set up Slurm accounting so the cluster tracks every job, every user, and every CPU hour. Previously, the software are built in shared software, Python, OpenMPI, GCC, and few others, all compiled from source. The cluster is now functional. The problem is getting to any of the software without doing path gymnastics every time you log in. And there is a second problem we had not touched yet. There is still no way to run a Docker container on this cluster, and for some software, a container is the only option. This episode covers two tools that fix both problems. First, Lmod, the module system used at TAC, NERSC, and many modern HPC centers. Second, Apptainer, for running containers on a cluster where nobody has root, including why Docker specifically does not work here, and how to actually build and run container images given that limitation. Let me explain Lmod first, because understanding the problem makes the solution obvious. We have software installed in shared software in version subdirectories. Python 3.12.12 is in shared software Python 3.12.12. OpenMPI 5.0.9 is in shared software OpenMPI 5.0.9. To use any of them, you need to prepend their bin directories to path and set LD library path for the shared libraries. Do that for 3 or 4 packages at once, and your path becomes very long. And getting it wrong means picking up the wrong binary without realizing it. A module system wraps all of that in a clean interface. Each piece of software gets a small file called module file that describes what to add to the environment. Lmod reads that file when you load the module and reverses it precisely when you unload. And Lmod handles dependencies between packages. OpenMPI on this cluster was compiled against GCC 12.5.0. Write one line in OpenMPI module file depends on GCC/12.5.0, and loading OpenMPI loads GCC automatically. Unload OpenMPI and GCC unloads too, unless something else needs it. Now here's a decision worth talking through, because I almost went a different direction with this. Lmod's upstream release is 9.2.6. Rocky Linux 10's own repository ships 8.7.65, a full major version behind. My first instinct was to build from source to get the current version, the way we built Slurm from source back in episode 5. But there's a real difference between those two cases. Slurm's distro package was missing PMIX and Sigurd version 2 support that we actually needed for this cluster. Lmod's repo package isn't missing any feature this series actually uses. A version gap by itself isn't a reason to build from source. So, we're installing from the repository. Worth knowing before moving on. The RPM isn't just a binary drop. It installs its own profile.d script and set up a default module path pointing at a couple of system directories we're not using. Our software lives in shared software module files, so we need to add that ourselves. Profile.d scripts run in alphabetical order. The RPM's own scripts are named with a leading 0, so they run early. One sets the default module path. The other actually defines the module command. Anything that calls module use has to run after both of those, or the module command won't exist yet. That's why this file is named to sort late alphabetically. And inside it, there's a small guard that checks Lmod CMD only gets set once Lmod's own init has actually run. So if something's out of order on some shell somewhere, this scripts just do nothing instead of throwing a command not found error. Module path is now added for Lmod. Now we need module files for our own software. Here is a Python module file. It has a help string, a few what-is fields, then path modifications. Prepend path adds to the front of the environment variable, and path join is a Lmod built-in that handles path concatenation cleanly. Here's Python 3.12.12 pointing exactly where we expect. The OpenMPI module file is almost the same, with the depends on line for GCC. One command, 2 modules loaded. GCC came along automatically. That's the whole Lmod setup. Module avail lists everything. Module spider searches more broadly. Module purge clears your environment. Good practice at the top of every Slurm batch script so job starts clean. One more thing was set up quietly back when we installed Lmod. A line that pins it in DNF config so our routine update doesn't change the version later. More on exactly how that works in a minute once Apptainer is in the picture too. Now the second half of this episode, containers, and why this cluster could not run a Docker container before today. Here is the problem with Docker on shared cluster. Docker runs everything through a daemon, and the daemon has a root privileges on the machine. When you run a Docker command, you're really sending a request to the daemon, and it does the work as root. On your own laptop, fine, you are the only user. On a cluster with multiple people sharing the same machines, giving everyone access to the daemon is the same as giving everyone root. No HPC center will do that. Apptainer, formerly Singularity, exists specifically to fix this. The core idea: whoever you are outside the container is exactly who you are inside the container. No daemon, no privilege escalation, no path to root through the container tool. A couple of other differences matter too. A Docker image is a stack of layers managed by a daemon and a local store. An Apptainer container is one file, a .zip file. You can copy anywhere with SCP and run immediately. And Docker isolates the container from the host by default. Apptainer does the opposite, shares your network, mounts your home directory, gives you direct GPU access. Because on HPC, you usually want the container to see your resources, not be walled off from them. And the good news is, you don't lose a Docker ecosystem. Apptainer pulls and runs Docker images directly. We can pin it the same way we pinned Lmod, in etc, DNF, DNF config, add exclude packages line with Lmod, Apptainer, and kernel. Since we do not want them to be updated automatically, we tell the package manager to exclude them from the list. This is a definition file, bootstrap, and from, pull Ubuntu 24.04 from Docker Hub as a base, files, copies a local script into the image, post, runs commands during the build, here installing Python, run script defines what happens by default when you run the finished container. You can build this on your local machine and upload the image to the cluster. Copy the file over with SCP. No restriction here, it's just a file. and run it on the cluster. For software that already has a maintained Docker image, you don't even need a dev file. Apptainer pool converts a Docker Hub image straight into a zip file. 3 ways to actually run a container, and they behave differently. Shell drops you into an interactive session inside a container. Execute runs one command and returns you to your normal shell right after. That's what you want for one-off checks or calling into a container from a Slurm script. And run executes whatever the container's run script defines, or the image's original Docker entry point if there's no run script. A few flags comes up constantly. --nv exposes the host NVIDIA driver inside a container needed for anything GPU related. On Corsair 1, with the NV flag, PyTorch inside a container sees the GPU directly. -B or --bind mounts a host path into the container, and -inv sets an environmental variable inside the container without touching the image at all. So that's a trade-off with Apptainer worth remembering. It solves the root problem Docker has on shared clusters. It's fully Docker image compatible, and it's great for reproducible, archivable environments. The full source for this episode, Ansible Playbooks, example module files, and the sample dev file is in the GitHub repo linked in the description. The blog post at theloginnode.com covers both troubleshooting sections in more depth. If this was useful, hit subscribe. Episode 8 is MPI on a budget cluster using the OpenMPI module we registered today. I'll see you there.